Hello there, and welcome to this quick clip going through a Friedel Crafts acylation typical exam question. So the first part is going to ask you to predict the starting reactants. So it asks you to consider compound P, which is formed by the reaction of benzene with an electrophile. They want the two substances that react together to form the electrophile and an equation to show its formation. So what you need to do is look at the part that is attached to the benzene ring. So this group that I've circled is going to be what the electrophile comes from. So the way it's going to work is that the carbon that's bonded to the benzene ring will have a positive charge on it. So thinking backwards from the structure of P, you need to come up with an electrophile that looks like that. Now, the issue we've got is how do we make this electrophile? So the positive charge will originally have to be the site of a carbon-chlorine bond, and a halogen carrier will take that chlorine away and leave the positively charged carbon behind. So the structure you're after for one of the two reactants is this, and the other one is obviously going to be your halogen carrier. You could also obviously have FeCl3 instead. So I'm going to put in the structure of my acyl chloride. You don't happen to remember, or don't have to remember that it's called propanamyl chloride, but just give the structure. That'll be fine. This will be sufficient, just this bit here. So your halogen carrier, it can be AlCl3 or FeCl3 like I've said, and the equation, when you draw out the electrophile, be careful to put the positive charge on the carbon that actually ends up being bonded. So this is the carbon that's bonded to the benzene ring. That'll be this carbon here. So the positive charge has to be on that carbon. That's quite important, and you could be penalized for pushing that positive charge in the wrong place. So the second part is drawing out the mechanism. So they want the reaction with the electrophile and benzene to form our compound P. So I'm going to take you through the key features of the mechanism. So the first thing is the arrow starts at the circle and points at the positive carbon. So it begins here and ends here. So you position the electrophile roughly at the intended substitution site. So obviously, if the substitution site is over here, you position the electrophile nearby to that point. And likewise, the open end of the partially delocalized pi system, which is this U shape with a positive charge inside it, has to actually face that site of substitution. So the curly arrow starts at the carbon-hydrogen bond. It's important that it starts on the bond and not at the hydrogen atom. So wherever the highlighter is, it starts on the bond and it points towards the open end of the partially delocalized pi system. So I'm going to justify why we have to have this H plus at the end. So in any mechanism, if you've got a charge, it has to move around as the mechanism develops. So the positive charge originates on the carbon on the electrophile, and obviously then it moves into the partially delocalized pi system before ending up on the H plus. So that is a way to remember to put the H plus in as a side product, because lots of people forget to do that from time to time. Okay, hopefully this has been a useful look at this question. Thanks for listening as always. Until next time, see you soon.